Of all the substances that are necessary to life as we know it on Earth, water is by far the most important. Even though 3/4 of our world is covered by water, only 6% is suitable for drinking. In fact, 1.2 billion people do not have safe drinking water. The development of water filtration devices over the centuries includes many unique systems, and few can claim the device produced healthy drinking water. An Australian invention called the solar water purifier will convert virtually any source of contaminated water into pure, healthy drinking water. This solar water purifier system has no costly filters, no electronics, no moving parts, and uses no chemicals to purify water. Simply, just add sunshine. By using the sun's energy to convert virtually every type of impure water into clean, safe, and healthy drinking water, the solar water purifier is the world's most advanced and efficient solar water purifier. The unit works by receiving impure water to an inlet at the top of a cascading tray. The trickle of water gradually flows down through each chamber to an outlet at the bottom of the unit. As the temperature of the water rises, droplets of water slowly run down the glass to a pure water channel, which transfers the clean water into a clean water container. A single solar water purifier works most effectively facing north in the southern hemisphere and at a specific angle of 12.5 degrees to the horizontal. The quantity of clean water recovered on a clear sunny day is about 6 litres per square metre at 20 degrees centigrade and around 9 litres per square metre at 35 degrees ambient temperature. Solar water purifier units can be connected in arrays of 4 units or 12 units. The array system enables greater quantities of clean water to be produced. For example, a 12-unit array system operating in southern Australia can produce an average 30 to 40 litres of pure water at an ambient temperature of 35 degrees centigrade. At a latitude of 20 degrees from the equator, the output from a 12-unit array may be around 50 to 60 litres at an ambient temperature between 35 and 40 degrees centigrade. Working at this ambient temperature, the water within the solar water purifier is heated to more than 85 degrees centigrade, and this pasteurizing effect partially kills bacteria and pathogens, dramatically reducing the risk of waterborne diseases. Prolonged exposure to ultraviolet light, transmitted by the special glass cover, completes the germ-killing process. Water output is purified to a level of 1 to 2 parts per million of totally dissolved solids, which is better than standards recommended by the World Health Organization. Operating solar water purifier systems have produced results with seawater which was initially measured at 35,000 parts per million, and the resultant output pure water was tested at 1 to 2 parts per million. That's a dramatic reduction, far greater than most reverse osmosis water systems. There have been cases where the local water was tested at 7,000 parts per million, and the requirement was to provide water for livestock at less than 3,000 parts per million. This was accomplished by mixing a ratio of 4 litres of solar purified water with 3 litres of local water. For human consumption, the recommendation from health authorities is to add about a cup of salt per 1,000 litres. Because the solar water purifier uses the sun's energy, it is very simple to use. And as it has no moving parts, there's hardly any maintenance. In fact, the cleaning maintenance is an easy procedure and is completed by simply adding a small quantity of citric acid to the input water. Solar water purifier array systems are an economical approach to providing safe, healthy drinking water for human and animal consumption. 12-unit arrays can easily be added to an existing array system with a small addition to the initial plumbing installation. Tank sizes for input water and purified water can be varied to suit the consumption and storage requirements. The advanced technology within the solar water purifier has been developed by Thamesford Proprietary Limited and has been promoted by Rotary International to many developing countries around the world. Thamesford is supporting Rotary's humanitarian program by donating a small portion of profits from the commercial sales of these solar water purifiers. Thamesford's involvement with Rotary in continuing a water humanitarian program has the potential to become one of the greatest contributors towards improving the quality of life for many people all over the world. At the present time, 6,000 people die every day from the lack of safe drinking water and sanitation. A child dies every 2 seconds, every day of the year. The solar water purifier is a cost-effective solution for the delivery of purified, safe, healthy water. Each single unit can produce enough water to sustain a family for a day. The safe, purified water output dramatically reduces the risk of waterborne diseases. Compared to many other water filtration systems, the long-term benefits, through no ongoing costs for parts, filters or chemicals, makes the use of solar energy the obvious way to go. Just add sunshine.
Tonight on The New Inventors, a simple way to clean polluted water, a strong metal chest that just folds away, and something to make sure animal traps don't trap you. Hello, I'm James O'Loughlin, welcome. Also tonight, more on what it's like to live with an inventor, and finally, a solution to the age-old problem of the runny nose. First, who are our judges? Well, tonight they are engineering professor and adventurous cook Veena Sahajwalla, inventor, journalist and guinea pig lover Christine Kaninmonth, and woodworker and former resident of Japan, Richard Vaughan. Welcome all.
Thank you.
Many people are inspired to invent when they encounter a problem in their own life. Others are inspired to invent when they see a problem that affects others. A few years ago, our first inventor visited Zimbabwe and he saw lots of people getting very sick because they drank polluted water. He wanted to help, and this is what he came up with.
If the only water you've got to drink is polluted, what do you do? I was inspired to create this low-cost, low-maintenance solar water purifier. The solar water purifier is a more efficient way to use sunlight to turn contaminated water into drinking water. The contaminated water flows into a series of heat-absorbing black plastic trays. The sun's rays pass through the glass. The infrared rays heat the water and the ultraviolet rays kill the germs. As the temperature rises, the water evaporates and condenses under the glass. The clean water trickles down the glass into a container ready for drinking, leaving impurities to flow into a waste container. I want my invention to help prevent disease and make clean water available for everyone.
Please welcome from Adelaide, John Ward. Hi, John.
Thank you very much.
Now, I understand your dream is that, and you've already got these in, over a dozen countries around the world, is that a family unit would have one and they'd be able to use it to clean dirty water and give them enough water to use for a day.
That's quite correct, yes.
Yeah. How much can it produce in a day?
2 to 3 litres a day if you live in a place like Adelaide or Sydney. But if you live in the tropics, 4 or 5 litres per day, which is enough for a family of 4 people to survive.
OK, now if we flick it on there, you simply put the dirty water in up the top, and down the bottom comes out clean water on one side and the dirty stuff on the other. What actually happens?
Well, normally you fill it with water. As soon as it's full, you turn the tap off.
Yeah.
The sun shines through the glass, heats the water, evaporates it, condenses and runs down into the collection channel. OK,
so it's actually the water we want, the clean water, evaporates and then condenses on the underside of the roof, runs down and then goes down that hole and into that side. So it'll eventually, it takes a bit longer, but you can see it dripping through there.
That's quite right.
Whereas the dirty stuff comes out, but you can put the dirty stuff through again, right?
If you put the dirty stuff through again and repeatedly do that, you can increase the concentration. So if you start with 1 or 2% of uranium oxide, say, you can change that to 25 or 30%.
Right,
and that becomes very valuable as a material which we want to recover.
And saltwater purifiers aren't new, obviously, but what you say is that this one is, I guess, more efficient.
It's twice as efficient as the best next one in the world.
And one of the reasons why it is so is because there's these lumps. We've coloured one in white. Now, what do you call those? Domes, yeah. And why do they help the process?
Plastic gets very hot when it's exposed to the sun and it grows.
Yep.
And the length in this box will change by about 25 millimetres in a day, and the sheet would deform. When we put the domes in, the domes go up and down.
Now, John, come and sit down. Now, Veena, what do you think?
Your purifier's output, is it greater than the other types of
It's about
purifiers?
twice as good.
OK, and how do you achieve that?
It's rather clever design in which the geometry of those little cells acts in such a way that you get far greater output over a little tiny cell when it's very close to the glass surface than you do if you have a big pool of water with the glass a great distance away from it.
Talking about what's actually in the water, what about things like bugs and beetles and algae and weed and things like that?
Perfect in every way. What you should do initially, if you have plenty of big beetles and fish even, then you put it through a dirty old towel, fill it up with dirty water, pour it through a towel, and that gets rid of the large lumps and particles, especially if you're dealing with effluent, say.
Richard?
Is it possible to bump that and either change the seal or spill some of the messy water into the clean water?
Well, we'll talk about the seal first of all.
Right.
There's a piece of glass and underneath it is a piece of plastic.
Yeah.
When the water vapour arises due to the heat of the sun, it tries to escape. It condenses underneath the glass surface, forms a film of water all the way around, surface tension. That pulls the glass down with a force of about 80 kilograms, and that's a seal. So every time you turn it on, you get a new seal, so you get no contamination.
Summing up, Ben.
John, with your engineering design, you really are solving a major social problem and also making a big contribution to a sustainable future, and that's fantastic.
Thank you.
Christine?
I think it's so clever because it's light and portable and very efficient.
Richard?
It's going to benefit a lot of people. You've made this little Leo sun worshipping, have another reason for worshipping the sun.
Thank you very much.
Good on you, John. Congratulations. Thanks for coming in. Please thank John Ward.
Thank you.
Thank you very much. And at the end of the show, we'll find out if the judges liked it enough to make it tonight's winner. Well, who will tonight's winner be? Whoever it is, they'll be in the running to be named our Inventor of the Year. So, will it be the water cleaning solar water purifier, the fold-away chest, the flexi chest, or the trap setting Little Ripper trap setter? Let's look first at originality. Veena, what is the most original?
Oh, I think the flexi chest has to be the most original. I mean, it is, you simply don't have metal boxes that are collapsible. I mean, what an amazing concept. Yes, we've seen collapsible boxes, cardboard and otherwise.
I wouldn't have gone on that one so much for the originality. I went for the innovation of the design of the solar water purifier as the more original aspect.
The design, I mean, that's the innovation. What a brilliant design. He's taken into account the fact that he's got to have the evaporation taking place, so that you need enough volume there. He's got the thermal expansion dome in there. So he's taken into account those factors.
I put the design on the flexi chest because of the functionality and tidiness of it, but the originality. So one way or another, where
Christine, design?
Design, I certainly think, yes, the solar water purifier is for the design. Because of this flexible dome system that he has.
Which one does the world need most, Richard?
Oh, very clearly the solar water purifier for me. It's not just because it purifies water in an economical way in either disaster relief or just places that are impoverished, but also because of the potential for cleaning up tailings out of mines and so on. So it's an enormous potential for that one.
Yeah, any disagreement there, Christine?
No, I think that's a very good one for need. And there is some need, I think, for the flexi chest, because I agree that there's a market out there that needs something that is fold away.
And even with the Little Ripper, you know, I mean, he has obviously recognised that there is a tremendous need in this particular area, because it is obviously a huge sort of safety consideration.
Which of the three will find a market?
I was going to say flexi chest, because I think there's a market out there that hasn't been tapped yet. So all the people out there who are buying the conventional chests, well, that's one market, but there's a whole market there of people who've said, I'd love one of those, but it never suited my purposes.
Richard?
Yeah, that fold-up chest's a good thing, but just, I guess I moved over to the commercialisation and in the manufacture aspect of things, which we mentioned before with the solar water purifier. But the potential for that chest, as you're saying, for the people with for the marketability, for the other uses, the campers and the temporary storage and, good as they maybe even removalists, if you're taking care of your own rather than bulk shipping. I think I'll probably come down for the water producer, solar water purifier on that one.
Who should be tonight's winner? Let's start with you, Veena.
It's the solar water purifier that's a winner, you know, in my mind, when you just take into account all of the factors, but most importantly, with the need side of it, it just wins over.
Okay. Either of you two disagree with that?
I think it's an excellent choice.
Rich?
We're unanimous.
It's unanimous tonight. The winner, John Ward, and his solar water purifier. Good on you, John.
Congratulations. Thank you very much for coming in, and good luck with it.
John's in the running to be named our Inventor of the Year. Well.